Okay, so before the break, we were starting to put together data class and focusing on sort of the idea of a data class, the stuff that would be in the database. And in our context here, to kind of put this in the situation, the examples like a chatbot on a used car dealer website. The information that chatbot will need at 2:30 in the morning to be helpful to the customer that comes to the client. So data fields to virtually represent the car, all private, and following good form, have at least our default constructor. We threw together a couple others that we thought might be useful, just to talk about combinations. Then all of our getters and setters for our data fields. We added a couple of interfaces. Serializable allows us to write this to a file. That's going to be important in a moment. I want to go ahead and mention that one immediately, because well, something we're going to talk about in a few minutes. And comparable as another method called compare to. And before the break, I could not remember the keyboard shortcut I used. And I tried to look up several, and I don't see the keyboard shortcut I'm used to using. So maybe that's just customized to a game engine that uses Java called JMonkey. That's where I'm used to using it. And that to make that, they grabbed the source code for NetBeans and extended NetBeans into the game engine. So maybe they just added that keyboard shortcut there, because I remember which fingers I used to press it, and I tried all of the buttons around that and it wouldn't work. But there's more than one way. So when this is underlined, the alt insert, what we were looking at to just generate code, implement methods is also on there. We have an abstract method that has not been implemented yet. So we can also just choose it from that list. That'll be a keyboard shortcut for now. So there's at least one of them. But maybe the one I'm trying to think of is only on JMonkey, because they took the source code for NetBeans and customized it into a game engine. And that is definitely where I'm thinking about it from. So, but we're going to implement it. Oh, then I put that at the very top. I'm going to cut that one out and paste this back in. Oh, what happened to it? Okay, I'll just hit Control-Z till I get back to it. So we had that comparable, so we had to implement this method compare to, or not just the equals, but the greater or less than, which returns a number. It's expecting some integer to be returned to, and the default, the general go-to is kind of what the machine does on its own when it does comparison. We just subtract them. Positive means the first one was bigger, 0 means they're equal, and a negative number means the second one was bigger. So as long as you remember which order you do that in, it'll work. And comments can be very, very useful for that. So we'll do that like a Java.doc comment. That's something people might want to know. So the parameter being passed in is the vehicle. We are comparing years with. It returns an int. If this is the bigger, if this is the newer one, so new minus old, if that gives us some, this minus other, so if that's positive, then this one is newer, it's positive. If the other is newer, it's negative. And if they are the same year, it's 0. So the little comment there that'll show up on that website when we generate that, so that anybody else that sees this object or goes to use it knows what to do out of it. In comparison between the years the cars were made. Something like that, a brief description, then the parameters that get passed in, and description of the return type. Enough that somebody could tell how to use that method. And we'll come look at those a couple more, because we should probably run a quick test on this, right? We did a bunch of stuff. Did I do a make, model, year? Oh, and remember our rules when we overload methods, because constructors follow the same rules. It has to be distinct. So we have one with two strings, takes the make and model, one with one string that takes the color, one with an integer, one with make and year. We should probably put a model in there. String, right over string, model, year. So two strings and an integer will give us that basic summary we usually give for a vehicle, right? Or we can use getters and setters. So we need a new vehicle. Run a test vehicle. V1 is a new vehicle with a make, model, and year. So like Ford, Ranger, 1993. We need another one. Oh, then that one's going to need a color so our sentence doesn't crash on this one. So v1 dot set color to blue, white, and then a vehicle. V2 is a new vehicle, and I'll just do all of this one to the other stuff. V2 dot set make, Toyota. V2 dot set model, Corolla, which I probably spelled wrong. I don't really know how to spell the word Corolla, the name Corolla, but something like that. V2 dot set color, green. That seems like it was a very popular color for Toyotas for a long period of time. And V2 dot set year. 2002. So some old ones. Then we should be able to print those out. S1, V1, and V2. Oh, whoops. Plus and V2. Plus and V1. All of that should look familiar. Does anybody have any questions about that part I just typed up? Just a quick test case. I was debating on leaving test cases for you all. I wanted to talk about other stuff, and y'all know how to run test cases. No error messages clearly showing up. A 1993 white Ford Ranger and a 2002 green Toyota Corolla. Looked like it was work. That looks like it's kind of working. Maybe check our equals. S out V1 dot equals V2. Oops. And S out V1 dot compare to V2. So false and -9, we did V1 compared to V2, So V2, that's saying V2 is 9 years new. That sounds right. So it looks like the test case worked. I was thinking about leaving that for you all afterwards, because we could probably do more testing. But that gets us sort of a start. What else did we have there? We had we need manufacturer. Oh, I guess the manufacturing place I just miss it. V1 dot manufacturing set manufacturing. Oops. Manufacturing plant, and I happen to know for certain that 1993 Ford Rangers were made in the Louisville plant. And the 2002 Corollas set manufacturing plant. I happen to know those were made in Georgetown. The Georgetown, Indiana plant. That's why I picked those old years. I knew people that worked in plants both of those years. Worked at one of those factories both. Actually, I probably knew more than one. I knew people that worked at both of those factories in those years. So I know for certain what vehicles they were making. But no error messages. I really printed that out. S out. And vehicle counter was static, so we have to go back to the class name. We can't do v1.getCounter or v2, so it has to be vehicle class.getVehicleCounter. Oh, 0. Oh, I guess we should implement that somewhere. We never implemented it, did we? So in our constructors, I'll say this vehicle counter. Why is it not predicting it? Plus. Did I spell it wrong? I'll copy and paste to make sure it's spelled correctly. Then I'll copy that and paste it in this constructor, and this constructor, and this constructor, and this constructor, and then we're down to the getters. So all of the constructors basically increment the counter, but hopefully that's some pretty sound logic that y'all figured out on your own without me explicitly stating it, right? Gotta have that counter there somewhere. We have 2 vehicles. So test case checking out. But we've seen that, and there's some other stuff I wanted to talk about this evening. In particular, what we do with this. Oh yeah, we have some subclasses. Y'all can make those subclasses, right? I see a head nod in here. We man the Zoom call and a little emoji or something. Y'all know how to make the subclasses if we jump onto the next content, right? That'd be good practice. Go ahead and do that. If I stop the screen share, you can probably take a picture of this. Take a screenshot of what's on the board there and make those. That'll be good practice on those subclasses. Because the next part, we might not necessarily need that. And we saw how to make subclasses the other day. There's nothing new. There wouldn't be anything new from doing that in class here. And even though we're in a 16-week class and it stretches out, we want to cover the new stuff, right? We don't need to see the same stuff we saw Monday. Oh, is it okay if I erase that? Did everybody get a picture if you want to keep that? We write that back up there. Y'all can finish out extending that and probably think of some other things that would go in there, which would be good practice, but it's the same stuff we did the other day. Oh, I guess I missed an error. Did you get a screenshot of it? Okay. Okay, so I'm going to erase this and move on to new stuff, because the parent class will be enough to show the example of the new stuff and then you can continue with continue it when you see the subclasses up. All right, so finally, I've been briefly mentioning this the whole semester. I know for certain I started talking about some of this stuff on day one. So the name of our language, programming language here, Java. I'll make that bigger. Got plenty of room here. I'm still in the mindset from this afternoon when I was trying to shove a whole bunch of vocabulary terms into my chalkboard at home. I only had an 8x4 board to write down all the vocabulary terms about networks, and there's a lot of them with long descriptions and long words and their definitions. So Java, referring to coffee, which is a slang term we don't really use for coffee much anymore. Very few people still call it Java, but at one point that was fairly common, so programming language was named after it. And going with coffee, beans are an important part. So there's this thing in Java called beans. You may have seen this word a time or two in package names or reference materials. Right? We're 5 weeks into our semester here. So you may have looked it up and seen that word already written. So what it is it's actually a manner of doing something. It's actually a manner of developing software. So here in a few minutes, we're going to look at something we colloquially refer to when we say beans. But what it really is it's a manner of doing stuff. And it's what we've been talking about. It's those conventions, the unwritten agreement that we all kind of write our Java code the same way. Our data fields are all in camel case, spelled out fully. Our method names are also written in camel case. Our class names are in Pascal case, spelled out fully, just like camel case, only the first letter is uppercase. Our package names are all lowercase. On the next page, when we do our getters and setters, or actuated accessors and mutators, when you're taking a multiple choice quiz, accessor or mutator, but everybody says getters and setters. Even the shortcuts in the IDEs are going to be labeled getters and setters, not accessors or mutators. Only certification exams will ask you that question, but it's certification exams, so you definitely want to make sure you remember those actual names, but it's not hard to think through which you either access the variable or get the variable, or you mutate the variable or set the variable. We added those words in, right? Get make, get model, set color, set year, and that one we just did. Follow those conventions. Do we have a Boolean on there? I think we had a Boolean in there, right? Nope, we didn't have any Booleans there. We had a Boolean the other day. I'll open the one from the other day. I'll pull up the one from the other day. In our getters and setters, get doesn't make much sense with the Boolean. So we say is, or sometimes has. To is another one, to string. We all just kind of do things the same way. That's what Java beans are. Think of it as super encapsulation. One of the goals of object-oriented programming is reusability of code. And we want, when we reuse code, we often find ourselves completely reusing the same objects in the same manner. Right? It's not, we create an instance of it, and it's not like every instance of that class is going to be different and unique. They're going to be very, very similar, and in a lot of cases, they're going to be exactly the same. We're gonna do exactly the same thing in this piece of software as we did in the software we wrote 30 months ago. Down to the values in every single data field and everything. That means that those could be consolidated even further into a single reusable object, not a reusable class. Does that terminology make sense to everyone? The class is the design, and then we instantiate a class to create an object. So if we're always doing the same thing, we can make a particular object reusable, not just the class, which is heading towards factories. We put together a bunch of constructors. That's one way to do it, right? We make the nice fancy object. We take all this care in it, build it carefully, and but if think about American world, modern American, just manufacturing history of manufacturing, right? There was a time where every product was made that way. Our real products, right? Every tool, every piece of furniture was handcrafted with lots of care and special needs, but we don't make that anymore. We have factories that spit out disposable ones as quickly as we can get them on there, right? Quality control is a big deal in modern manufacturing because we spit out so much junk that half of it needs thrown away before it leaves the factory. Nobody pays attention. We can do the same thing with our objects. Instead of having that big fancy one, we can make a whole bunch of disposable objects so that instead of calling a constructor and making one and keeping it around using a RAM for a long period of time, if we need a method, we could make a version of it, use that method, and delete it immediately. Delete it on the next line. A bunch of quick disposable objects for factories. So we're heading towards that way. In this stuff is sort of the first step there. There's even stuff that goes beyond that we'll probably run out of time for tonight that shows up in the spring, in the frameworks, especially spring, or when it gets really, really, really big, when we need like thousands of factories running at the same time, because there's 50,000 employees and 10 million customers trying to access the same database at once. So it goes for a while, but hopefully that makes sense, the reusable part, right? Not just the reusable class, but the actual instance of the object, make that reusable. And colloquially, that's what we're referring to when we say bean. Bean is actually refers to the manner that putting all this stuff together. And there's also something really, really awesome that comes from that, from Java Beans properly, the manner of doing this, is that we know how we wrote each other's code, which means we don't have to just parse the output of somebody's code. We don't have to deal with the output of somebody else's code, even if we've never looked at it, because we know the manner in which they wrote the code, which means we can dynamically change their program instead of just parsing the output of the program. That's a power we usually don't have in most of our other programming languages. Somebody else wrote code, we have to deal with the output of their code, and that's it. But because of beans, that unwritten agreement, things will compile and run fine if we don't do it this way. But when we do it this way, we get so many more advantages that it is treated as it's part of the Java programming language. Like your stuff will compile and run, but other programmers would look at you and say, I thought you said you knew Java. That's not how we write stuff in Java, because they're referring to the beans, because we get so many more powers from things like we'll see when we look at JavaFX tables and observables. We don't have observables in most of our other languages. We can't even consider it in C++ or Python. So it's doing things the same way gives us a lot of power. And the first one we're going to look at is the reusable objects, not just the reusable classes. Not just reusable in this piece of software. 10 years from now, maybe somebody needs that class we just designed. They need to be able to download that from the internet. They need to download that. They need to pull that off GitHub and run it right in their code without reinstantiating it or anything. That sort of reusability. And the actual class is long gone, but a particular instance was saved, and they can pull that down and use it 10 years from now, even if there's no way to reinstantiate another object without rewriting that class. So a single reusable item. We reuse code all finders of the same manner, which means that we could be consolidated into a single reusable item, at least if there's a way for our super item to modify instances of the object on its own. If it can handle that stuff, and that comes from those conventions. Really getting into observables, but there's still a whole bunch of technology, a whole bunch of terminology and concepts we need before we start talking about observables. So our conventions, let's just list those out here. List on the board here, yeah. So we're past shoving everything into the main method, right? That was, everybody understands that was just the first 2 weeks getting used to this syntax. So now we're into proper object-oriented Java. So we're talking about that now, not the main method. The main method just instantiates whatever object we need to run. That just starts our program. So now we're putting together the pieces for the actual software we're developing. So private data fields. In camel case, or all caps for constants. And all caps includes underscores, if that kind of looks like an extension on the L. So all camel case, all the words are jammed together, and then the first letter of each word starts with capital letters, except for the very first one. All caps is like it sounds, all capital letters, and we use underscores for constants. I don't think we've seen too many of those in our class examples, but that's our Bean mannerism for doing that. We have those keywords for when we move those data fields into methods, so public methods, so we can access them. Get will return a value. Set to change a value. Is return a value on a Boolean. Return a Boolean value. So I guess that's a special case of getters, but it makes more sense when we say it that way. When we go to talk about it, sort of the self-documenting code idea. And then 2 for specific use. Which we've only seen one so far, 2 string. But there's others. 2 hash key. Not Twitter hash key, the thing Twitter hash keys are named after. We're going to spend a big deal on that because that's an optimal search thing for the computer. We'll look for a while at hashing. 2 number. To get, if we have a string, can we turn it into an integer or a double or something like that? So basically this is casting. Is everyone in the room on the board? I think they're in a room on the board. All right, on this side. The 2 keyword for casting. So 2 string takes our object and turns it into a string so we can print it out. But in the more specific case for whatever we want to use, to a hash key, to a number, all of that stuff. Yeah. Hash key not a hashtag. Hashtags are named after hash keys. Because that's how the Twitter algorithms search. They have very, very big databases to search through, so they have to optimize that search. We already saw some parts through our code, and we'll see before long that when we follow these conventions, everybody follows these conventions, we know how other programmers wrote their code. So we don't have to just parse the output of their code, we can parse their code and change it. We modify their code on the fly. Very, very powerful thing we don't have unless we follow these conventions. So it's definitely worth the time. And in order to be a bean, it has to do all of this and implement serializable. That's our rules. 1, 2, 3. Implements serializable interface. Which is really the reason we did that a few minutes ago, because I knew we were going to talk about this. We have to implement that to write things to a file. So I thought I'd mention that first, but it's one of our rules because of what's on the next page of my notes here. Oh, and it must have an empty constructor. 4. Must have empty constructor. But since Java, like one of the later versions of Java 2, we're on Java, we're way past Java 2. Java 2 was like phasing out in the late 90s. So the rule is still written down, but since then the compiler will add the empty constructor. We don't put one there, but it's not hard to type it in our code. That's the constructor that doesn't take in any parameters and then just has the opening and closing curly brace. So it's really not hard to type that in. But those 4 rules, if we follow those, we want to make our beans as easy to use as possible. So we need some bean info, kind of like telling others what to do with it. And I've already stated a couple times, object-oriented is for the human, not the computer. So it's terribly inefficient. So it'd be nice if we could do that in sort of a format nicer for the computer. And something we've looked at before, I haven't paid, I just kind of glanced at it on the screen. I'll pull this up. I think I'll need to create a Maven project. Where do we at? Yeah, I'm going to create a generic Maven project real quick. Maven application. I'm just going to point at a file here and delete it. While that's creating, come over here to where this is saved. NetBeans project. Here's the one from tonight. And it builds the manifest on the fly, so we don't have a manifest yet. But when the manifest is written, it's written in XML. It generates an XML file for the computer. Our build file, oh, whoops, that's not a build file. Our build file is also written in XML, so we'll look at that. So those background instructions that we give the machine, which I guess I can just open it that way. Google Chrome will show XML stuff. It's written in extensible markup language. So we have our tags, the opening and closing tags. There's a lot of comments in this one. All this other stuff that we can do here that's kind of turned off by default, but a markup language, which is a whole lot easier to do with markup languages if the computer does the typing. If we're not the ones that has to type all of those tags, that gets a little bit tedious. But if the computer types the tags for us, that's super easy to deal with. And the biggest thing about markup languages, we're going to close that, come back over to that Maven project's created now. So on the POM file, the project object model, that's also written in XML. Have all those opening and closing tags. And The thing about XML, that's the reason our markup languages in general, is it's a really good form for the computer and the human both. It's the best middle ground we can get. When we have a long string of binary data, like what's actually going on in the machine, nope, wrong button. I'm at the stage right, not the right button, or stage left. When we have all those ones and zeros, the computer knows what's going on there. We don't have a clue. But the format that's in, that is just an arbitrary string. I just completely made that one up here. There is a particular format that's in, so the computer knows what to do with it. And that format is going to be something like start. The computer is going to know where a particular piece of data starts. Part of that code says the start point. Part of that code is going to say the end point. And it's going to be in that order, right? Start at the beginning and end at the end. But right after the start, we'll have some metadata about our actual data. I'll just write data. So here's the data we're working with in our software. Right before that, we have some metadata, and we have where it starts and where it ends. And since we're just talking about markup languages, hopefully that structure looks a little bit familiar, right? Everybody's seen HTML, right? Okay. Everybody had the 153 class, or we've seen it some in here. So we might have, I'll use HTML for a markup example. A paragraph, class is, I don't know, P3, just to keep it short here on the board. ID is summary. Some useful word, I'm just making that up, obviously. Close that. We'll put our words there. And then our closing tag. But look at that format. It's in human readable form, but it goes in the order start point, metadata, our actual data, and the end. That's the nice thing about markup languages. It's not fully computer form, right? The markup language is entirely Unicode, so we have to translate that over to numbers. So there's a step there, but it's a lot closer to the form the computer wants it in, and still in human readable form. So markup languages give us that nice middle ground. That's why we see them so much. There's a nice middle ground where it's a good form for the computer and it is fully human readable. So doubly advantageous because there's not many middle grounds we can actually find there, right? A lot of times when we're talking about what's going on way at the binary level, we have to completely abstract it and talk in analogies. So it's nice when we have that middle ground. It's way more efficient. So that when we lose efficiency for object-oriented programming, markup languages like XML are a way that we can get that back. Machines are fast. It'd be nice if it's nice when we can run them faster, right? They're machines. People are familiar with cars. Think about fast cars. The new model of Corvettes are pretty fast, but when you put high octane gasoline and a nitrous tank in there, they're faster. Okay, so if we can make the improvements, it's good to do so. And with our typical use for Java, we're talking big software. Java is for enterprise systems. Java is for big things. Some of y'all live elsewhere in the state, and there's similar things there, but here around Louisville, this is the headquarters of Humana or UPS. UPS World Hub is here in Louisville. Everybody knows UPS, right? It's a big system. How many employees does UPS have? There's a lot, right? But the software to keep all that together. Oh, at the NVIDIA conference the other day, he said that he mentioned how many developers he has, how many programmers work for the CEO. Anybody watch that keynote and catch that number? He has over 1 million software developers. And that's the software isn't even NVIDIA's main thing. That's a big worldwide company. 1 million is a tiny fraction of 7 billion. So it's a small part of the world, but that's a huge company, right? Over 1 million of in the millions of employees. So when there's millions of people using that same software concurrently accessing the similar databases and stuff, those milliseconds and nanoseconds that we lose add up. Right? For something small or on a desktop, it's like, okay, we take our measurements when we're debugging it. Oh, we lost 2 milliseconds. That's not bad. But then if 3 million people try to use that software concurrently, okay, let's throw the math on the board. We lost 2 milliseconds. So minus 0.002 milliseconds is what we lost from a little bit of inefficiency. But if we have 2 million people, so something like Humana, that's the example I often go to, here centered in Louisville, but international insurance company, 50,000 employees, 10 million customers, UPS, essentially 7 billion customers. If we got numbers like that using the software, let's say 1 million people times 1 million people trying to use that all at once, it's going to be a big number, right? 2 times 10 to the negative 3 multiplied by 1 times 10 to the 6. And that 2 milliseconds we lost isn't a small deal anymore. 2 times 10 to the 3rd. We've lost 2,000 seconds. Those milliseconds and nanoseconds add up when we get to enterprise scale. So any place we can buy back healing efficiency, it is worth doing so. That's the reason we're talking about this, because we're running on very, very fast machines, right? Modern machines, it's rare to find things that don't have a lot of cores. I use the cheapest machines at Walmart. I go to Walmart, and this one right here, I specifically went in Walmart and said, I need the cheapest laptop that runs Windows. My Chromebook didn't break on me, but I need a Windows machine by 8 o'clock in the morning. And if I pull up the numbers system, so specifically asking for the cheapest laptop on the shelf at Walmart is the Intel i3 4 cores with 3 gigahertz, 4 cores of 3 gigahertz, 8 gig of RAM. There's a 4 gig GPU on there. That's pretty good for the cheapest laptop there is, basically, right? The cheapest laptop at Best Buy would be a whole lot nicer than that still. So machines are really, really fast. We might not be losing much, but it adds up when we're talking about enterprise scale systems. So that's why we want to consider those things. And, well, I ran out of room on the board. So to reuse those objects, We can turn it into an XML thing. And actually we kind of have to. So you take the class name and append bean info on the class name for a new Java file, and that's what the IntelliSense actually queries, is the Java bean file. And other things that might need to query that file. We'll see more examples of that. It's gonna make that, it'll make that file for us. Oh, and then we can just turn our beans, our data objects into XML format. Because XML is not bad when we're not the ones that have to type all those tags. It's a little aggravating to type all those tags, right? That's time consuming. And everybody had to take that SDEV 153 class, not because you're going to be typing a lot of HTML. You're on the pathway to write software that's going to write so that other people don't have to type those tags, right? So artists can drag their mouse around. So you're the ones that will write them, but you're going to write them inside of methods, printing text files, right? So that artists can drag their mouse around. But you only have to write it once in the method. And somebody already did that in a lot of Java. So we have this data object we created. Let me close out the extra objects here. And then what we want to use here, right? This is an XML file. So it probably, when we do an import, when we bring in a dependency, we create our dependency tag, which I think I can probably do one this way really quick. Maven fxml, that'll work. This way I'll have a dependency tag, so I don't have to type one. So I don't have to type that XML at that point, I was just making it. A lot easier to deal with when the computer does that part. It should just take a couple seconds. It's not a big file to download. Comparatively, it's not really a small file either. But, we're going to look at JavaFX later, and we'll look at it as Java objects. But there is a markup language version of that available. Non-dynamic things, that's what this is leading into. Non-dynamic things are better as a markup language. And our graphical user interface is usually pretty non-dynamic. Then, like here in NetBeans, things change in the editor, but where the editor is at doesn't change. These buttons do not change. Right? They highlight a little, and we can click them, but they're pretty much set. And that sort of thing is, they're not changing, so they're better off as a markup language. So we're going to look at JavaFX in Java objects, but it's actually better to use FXML. So we'll kind of sneak that in at the end, I guess. So the POM file here, this one has dependencies, so it needs other libraries. It depends on the OpenFX library. So bringing these things in, these other libraries kind of need versions that are set up in XML format or something more accommodative to work with XML than Java scripting itself, for lack of a better word. I think you all know what I'm talking about if I say Java scripting, right? The stuff we're mostly studying in this class. So I knew those Maven projects would be at least a good spot to point at. So to make those things, so like we have two objects here. Maybe we want to reuse them over and over and over again. So let's look at an example of doing that. So I'll open my example here, so I don't point at too many things. So I'll just do it as a, I'll just make another method to do it. So a public, and I'm just going to do the static thing. just for quick and easy. For the example, normally this would be a normal method in a class that we would use. But kind of like the textbook uses static because they haven't talked about instantiating objects at the time you see it in the textbook. So a public static method doesn't need to return anything, and I'll just call it make beans. And what it's going to do is it's going to take in a vehicle object. I'll call it V, and a file name. And it's going to write that these objects we just created, these objects we instantiated, it'll put those in XML format. Because these are just data objects. There's nothing dynamic there, right? There's nothing dynamic. So once we create it, we can put it in XML form, and then if Java needs it back in the Java object form, it can do that, and we get more efficiency out of the language, out of the software overall. We don't risk losing 2 milliseconds, which would add up at enterprise levels. So this, we're writing a file, kind of like we saw before. We'll need to put it in a try catch block, which we haven't really looked at yet. Tag trace. What's wrong with the exception? Did I spell that wrong? So somewhere down the chain of inheritance in the objects making up the Java language, there's an object called exception. And we have lots and lots of exceptions that are more specific, but every exception has to inherit from that basic one. So this is kind of like the version of object for when things go wrong. For the classes where things go wrong, when exceptions get thrown, all exceptions inherit from that one. So it's a good catch-all. And now for writing the file, I'm going to use an encoder. So I created this XML encoder. I'll try to E for encoder. XML encoder. And move stuff out of the way. So we have it's going to be a long string. I thought about doing this over several lines and then just like, well, excuse me, this is kind of preview mode. So I'm going to do it in more of a preview of what the end result's going to be. So this one's going to look like a mess. So our new XML encoder needs to take in a couple things. It needs a buffered string is what goes in here. So into that constructor goes a new buffered output stream, which we'll see what a buffered output stream is before long. But a buffered output stream, the constructor for that also needs something. It needs a file output stream. Well, it needs a place to go. In our case, you can see up here, I already called it file name. So we're sending that stream to a file. So it needs a new file output stream. And then the file name .xml. Oh, whoops. Zoom things are in my way. I gotta move those. File name flood plus .xml. So I'll just pass it in that way. And it's probably, I have to import some stuff. Maybe that's why it's underlined. So we need to import the IO stream, import the XML encoder. Did I spell something wrong there? Buffered out. Oh, yeah, I did. Buffered output stream. There we go. Now I should import. Yeah.
I'll put a semicolon there. 1, 2, 3. 1, 2, 3, semicolon. Why is it telling me that doesn't?
You're missing a slot after E.
Oh, thank you. Missing the equal sign. There we go.
That's a messy line. But I wanted to work in some lines like that before long. You will see a lot more of those in Java. Those are kind of a introduction to what I'll sometimes refer to as SA linked variable names. Okay. That's a long name for that object, but it's very descriptive on what it does. It follows our pattern here. And then we nested them inside of constructors. It can be spread out amongst multiple lines, but you'll often see stuff like that in Java code. So I wanted to start typing that pretty quickly so you get used to seeing it. Does the line itself make sense to everybody? Anybody have any questions? Well, I'm sure you have questions because we haven't talked about what a buffered output string is, but you know what a buffer is, right? Instead of sending all our data, we break it in chunks. We'll send 1,000 bits at a time. 1,000, we'll say our buffer is 1,024 bits. So we got the first 1,024 bits to send that. Next 1,024 bits, and that's an output stream. And file output stream, obviously we're going to a file, but in particular, we're going to do it in buffered styles while we're doing that. Then XML encoder, the name kind of says, oh, we're going to encode something as XML. But we will see a lot more Java code that looks like that this semester. So I wanted to get to that pretty soon. Now that we have our encoder, we can just say e.writeObject. Write expression, write object, write statement. We want to write an object. And the one we want to write is this object we passed in right here, our vehicle object B. Which you'll remember we did implement the serializable object, serializable interface. So we are able to write that to the file. Then we can close that. E.close. If you wanted to, you could S out success. Maybe on our exception instead of the stack trace, I'll just whoops. That must be how I keep accidentally deleting those curly braces. Failure. Just output some message, which isn't really handling the exception, because if we didn't handle the exception, it would stop running and give us a message. We'll look at that soon, but that'll write the thing. And we're running short on time, so I'm just going to go ahead and do the read real quick. Be very, very similar. To make it quick, public static void retrieve beans. And here all we need is the file name we're looking for. What file name do we want to read? Oh, and this one we want to return an object. So in our case, we want to return a vehicle object. Or vehicle type of data. Just in case we need to get it back from that XML file. Again, we're messing with files, so we need a try catch block. And I'll just print the stack trace. E.print stack trace. But that is exactly what would happen if we did not handle the exception. So it's just because the compiler makes us do that if we're going to work in files. Like, no, the file might not be there. You have to handle a possible exception. So to write it, we had an XML encoder, so you can probably guess that what we need for the other way. I put both of those onto the screen at once, kind of barely. You can probably guess
We need an XML decoder. And I keep erasing curly braces. I keep bumping my little touchpad and highlighting extra things and deleting those. So we'll have a decoder, I'll just call it D, and that's going to be a new XML decoder. And the constructor is going to look a whole lot like the previous one. Again, Control-Shift-I to handle the imports. And our constructor is going to look a lot like that one, only the encoder, sending it to the file, we needed a buffered output stream. So to bring it back in, we need a buffered input stream. And that buffered input stream needs to take in a new file input stream. And that file input stream needs to take in a file name. So as you can see, it's a lot like the other one, only we're doing input. You just have to remember which ones are inputs and which ones are outputs. The file name plus .xml, which we could pass in. I'll just, the way I write code, I like to just use the human part of the name and then the code handle the extension. And once again, I'll click over here this time, click here for the inputs or Control-Shift-I to get all those imports. But that nice long string, I wanted to preview that as soon as we could. We're going to see a lot of Java code that looks like that. Which that line is, those two lines are probably actually a better preview of Java syntax than anything we looked at those first couple weeks. We're going to write a whole lot more code that looks like that. And part of the looking like a mess is just spelling everything out correctly, right? If we abbreviated all that stuff, it would look a whole lot shorter. It wouldn't look bad at all. And hopefully the conception makes sense. To fill parameters, we're just making anonymous ones. Instead of saving it somewhere to some reference name and use that reference name, we just do the constructor for the other one right into that parameter. Because a human never needs to look at it. That's for the machine. We will see a lot of code that looks like that. And like I said, in a lot of ways, that's probably a better preview of Java syntax than anything we looked at the first couple weeks. It looks like a mess, but it's hopefully it doesn't seem that bad. We've talked through it and seen where it's coming from, made sense of it, and we're going to talk about the streams before long anyway. And at the end of the semester, we'll make new kinds of streams on our own. Your last homework assignment of the semester, you're going to make a new type of stream. See what's going on with that. Well, up above, once we had our encoder, we write the object. So you can probably guess pretty quick that now we just need to read the object. Except if we're reading it, we need to put it somewhere. So we should be reading some vehicle data. I'll call it V. Is D, the decoder dot read object. But D.read object doesn't really, it's read object, not read vehicle. So once again, it's going to return a regular object. It's going to return an instance of object, not an instance of vehicle. So we need to do some casting. Then we can close that. We're done reading. Close the file when we're done. Just like always. As humans, if our cursor's in the wrong spot, we'll notice it pretty quick. We're intelligent. If the computer has focus in the wrong spot, it's not going to notice it. It's just going to do stuff. It's just going to do stuff in the wrong spot. So if we open a file, make sure we close it. Oh, and then next we can return B. And well, actually, return has to be the last thing. So before returning B, I'll print success. Which would come out of the final version, just a little echo to help us testing and stuff. I went about 5 minutes longer than I was thinking. Does anybody have any questions about that? So kind of preview mode, looking at that messy syntax. Y'all have seen markup languages before. Typing tags can be a pain, so we want the computer to type the tags for us. That's one of the ways we have to type tags. There are lots of them, and in particular, this is specific for beans. If I come up and look at those automatic imports, you'll notice that that encoder and decoder came specifically from the Java beans package, which is our conventions of doing things. So those are set up to work with private data fields, and camel case are all caps for constants. These specific keywords on the getters and setters, the serializable interface, and the empty constructor. So it's going to use those things every time. So I guess finish out class, we can go up here and do that. So there was our test case from earlier. The test checked out. So this, I'm going to write those. So make beans with V1 and make beans with V2. Oh, I forgot the file name. V1 was a Ranger. So I'll make that, put that in a file called Ranger, and V2 was a Gorilla. So I'll put that in a file called Gorilla. There's my error, or is it just not cleared out yet? Oh, and notice over here, over in the scroll bar, there's the warnings and errors show up. What's the error? Oh, not all paths return something, returning null. Null is emptiness. It is a specific data type. But it's the less than nothing. Electrically, that's where we don't care what's going on. We just leave the electricity flowing. We're not going to empty the registers. We're not going to put anything in them. We're just going to stop paying attention to the registers. So that it's really not a nothing. It's like, it's a more of a, we don't care what's in the register. Don't look at the register. Don't give us what's in the register. Just give us random electricity. We're not going to use it anymore. The same thing to read those. Well, I'll write them and read them at the same time. S out retrieve beans. And I want Ranger and S out retrieve beans with Gorilla. Did I spell that wrong? I did. Spelled it wrong somewhere. Yeah, I first. I had to think about that for a second. But that's returning an object, so I'm just going to print it out immediately. So whatever the return from that is going to print out, and there is a default return for the object that should be written in that file. So now we can check. There's not much time left, so hopefully I didn't make a typo while talking. If we run that code, see the word success on there, and get these out of the way. Okay, yeah. So success, they were both written to a file. So then these outputs should have come back from that file. So let's go look for the file. We didn't pass in a file name. So this was the alternative. I think the other day we saw where to put, when we made that little database example, we saw where to put it. This was my alternative for how to show you where to put it. Notice the top level of the project. We didn't pass in a file name, so it put it up here. We go to NetBeans projects, objects example 2, and there's those 2 XML files. open with, yeah, I guess that works. Yeah, get nice and the collapsible options here. I meant to open with Sublime. I clicked open instead of open with, didn't I? Why is there no open with? Okay, I'll do it this way. Go in here and open folder, advanced projects, object 2, that folder, and then I have that and that. So you can see the XML stuff all written out nicely in pretty print. That's what we usually don't get when the computer writes XML. Most developers just send it as one long line because it's for a computer, not a human. And we can, like, browsers will automatically open it in pretty print. So we can do that if a human needs to read it. But you see the XML tag and then what version of Java it was compiled in. So that's our Java compiler that we used. What class and what class needs to decode it. So it was encoded with the Java Beans XML encoder. So to decode it, we specifically need the Java Beans XML decoder. Some metadata there. But then we have an object tag with a property called color. So notice our actual data field name showed up here, and the value showed up in a string in a tag indicating it's string type data. Y'all can look through there, you'll see all the familiar stuff that we just made, right? Our actual data field is a property attribute in this void tag. All that stuff, and we have almost identical thing over here. Oh, that's the build file. I'm going to open the Ranger file. There we go. Now almost an identical thing here. And if you shouldn't have to stare at it for long to see the connection between what we typed and the XML version, which we're looking at in Unicode, but a computer, if we use that immediately in our code, wouldn't necessarily have to look at the Unicode version. It could keep it in something more closer to the computer-friendly version. And we didn't have to write all those tags to get efficiency back on those data objects, because the object-oriented version, terribly inefficient. XML gets us back some of that efficiency we lost. So a few more things there. Does anybody have any questions about those? That is the first sort of benefit we get from Beans, is that we can quickly turn things into a better format. There's no activity in our object, it's just a data object, which is what your first assignment is. So that picture that was raised earlier, if you're following along or download this from GitHub afterwards, I'm gonna put it up on GitHub here in about 5 minutes. Extend that into make those child classes that were on the board earlier. That's good practice. And that's sort of what your first part of the homework assignment is. I would like you to do that part now so that you have some practice before we get to the next thing. So that you're used to that basic data object. If you need a situation, think of like a retail website. You have stuff stored in your inventory stored in your database, and you need to get it to the dynamic programming to interact with the users, for users to click on, query about, chatbots to know about, and all that stuff. So think about the data objects kind of like we did here, and get some practice with that before we move on to the next thing. And subclasses, but we saw subclasses the other day. And if you want to try the serializable thing, but you probably want to do comparable in most situations. You want to know which ones are bigger or smaller, or in retail situations, better or worse. Right? 5-star versus 1-star. That's probably a good way to compare things if you put star values in there and take the retail one all the way. And then the beans are very, very useful. These files will be up on GitHub in just a couple of minutes before I leave this room tonight. Otherwise, does anybody have any questions? That went about 10 minutes longer than I was anticipating. And I guess there's only about a minute left last time. So y'all have a great weekend. If you have any questions, let me know. Text messages and I relearn messages are two things that make noise on my phone. So I will get back to you very, very quickly. Y'all have a good one. Enjoy that nice fall weather. And the stop button is on this computer.